Now, before we look at integration with terms like this, we're going to actually look at differentiation to see what happens. So we're going to look at the chain rule just to refresh our memory, and we're going to use what we note to help us on the next section. So when we differentiate this, if we've got something raised to a power like this, remember to bring the power to the front, decrease the power by 1, but then we also have to differentiate what's inside the parentheses. So the differential of sine x is cosine x. So if I asked you what the integral of this would be, then obviously the answer would be this, because we're doing this in reverse. So when we have two terms together like this, and one of them is the differential of the other, then that tells you that we're going to do the inverse chain rule on this part here. So you can already see that we're starting to increase the power by 1. And we'd also have to divide by 3, which would cancel this 3 out as well. But we'll go into that depth a little bit later. Now, if we differentiate this one here, same idea. I'm going to bring the power to the front, leave this alone, decrease the power by 1, and then the differential of cosine x is negative sine x. So same idea to notice when we do this question in reverse later. If we have something raised to a power, but we have a term out here that's the differential of this, then we can actually start applying the inverse chain rule on this. And once again, you can see the same thing, that we're going to increase the power by 1. So that should help to explain how we're going to do the next section.